And I hope it's obvious to you. We could have all sorts of fun, right? I mean, there's probably 100 different kinds of probabilities that we could tinker around with, right? So I just picked a few that are representative of the general case of hey, what's the probability of this? So, what's the probability that a student is taking only one type of the three? Okay, so what that means is that a student that would fit this would be taking only a technology class. So that would be this area here, right? It would exclude any intersections. Do you see that? But that would also have to be unioned with the probability that a student is taking only an arts class, right? Which would be this red area minus the two intersections. And that would have to be, that probability would have to be added to the probability that a student is only taking a math class or math classes in general, right? Which would be this area, right? And I've said, I've actually, in my description of the problem, I've used a couple of the axioms, right? I said that we would add these three areas, right? Well, we have to do that, or we can do that by rule of mutual exclusion, right? This pink area right here, this area right here is mutually exclusive from this area right here, is it not? Yep. So since they are mutually exclusive by axiom 3, we simply add the probabilities up. Does that make sense?
Mm-hmm.
Okay, you guys ready to roll? From the Venn diagram, it's probably not real hard, right? We just have to find what's the area of T right here that is missing the two intersection. Well, actually 3, right? It's missing this football area and this football area. What is that probability? Okay. So you're doing the set, right? Okay. I was doing probabilities. Let's do it your way. So only T equals the intersection, right, of T intersect the inverse of this triangle, right? Or I'm sorry, the football. So T intersect A inverse, right? Right? Yep. So what that would do, though, is it would give us this Pac-Man looking thing, right? Because T is the bubble, T is the circle. So if we intersected it with T intersect A, the inverse thereof, we would subtract that football out, so that would leave us the Pac-Man looking thing, right? Right? Yes, no? We still have to subtract this out too, right? This football. So we have to intersect it with T intersect M, right? So it's the intersection of all three. In terms of probability, it's probably a little bit easier looking at it in terms of probability. If we take the probability of T, that's the probability of the whole circle, right?
Yes.
So it includes the intersection, the footballs, both footballs, and it also includes the probability of all three, right? So we have to subtract out this football, right?
Right.
So that's minus probability of what, guys? Isn't it A and T? A intersect T, probability of the intersection, right?
Yeah.
And we also have to subtract out this football, don't we? Right? So we subtracted out this football and we subtracted out this football. What's the problem?
We took out the triangle twice.
So we have to add the probability of the intersection of all three, right? Back in. Okay, what do you get for T only? And can I get rid of this stuff up here because I'm running out of room?
Yeah.
Going once, twice. Okay. So what's the probability of T only, guys? What's T? 0.5? What's M and T minus 0.37 minus what? Yes, no? That's M and T, right? This is M and T, this is M and T, what's this? This is A and T plus 0.05, yes, no? What do you get? I think I get 0.03 or 0.03, right? Yes, no? A little bit misleading from the Venn diagram. It's very misleading. The problem is these footballs, especially this football, M and T. This football right here should be much, much larger. So, oh well. So guys, we found this area right here. We have to find A only, and we have to find M only. We have to add them up, right? Right, guys? Talk to me. Do you buy that? Okay, let's do it. The work is very similar, is it not? The process is very similar. What's the probability of A only? probability of A minus the two footballs, right? Probability of A intersect T, we already have that, minus probability of M intersect A, right? Plus probability of all three. What do you get? What's A? 0, 4? Minus A intersect T, what's that? 0.15? Minus, what's M intersect T? No, M intersect A, I'm sorry. What's M intersect A? 2, 2?
Yes.
Plus 0.05. I get, what do I get? 0.8, is that right? 0.25, 0.3. Yes, no?
Yeah.
And we got to do M only, right? Right, guys? Talk to me. Here we go. You do it on your paper, and I'll do it up here. We'll compare notes. There's no tricks. What's M? 0.6. I get 0.06. Is that right? Yes, no?
That's what I got.
Was that Chris or Liam?
It's Chris.
Good job. So the probability of only one equals 0.03 plus 0.08 plus 0.06. What do you get? 0.17? Okay. Guys, that's how you do it. Are there any questions? Any questions whatsoever, guys? Talk to me.
I think that was a good refresh.
Was that Charles?
No, that was Brian.
Brian. Oh, of course. Yeah. Talk to me, guys. I have to. Oh, I forgot important dates. You guys should have reminded me. What can I get rid of? Do you guys want to take a screenshot and throw it up in the chat? Because this is kind of a nice little summary here.
Yeah, give me 1 second.
We got a lot of mileage out of this example, didn't we?
Yeah.
And guess what? We're gonna get even more. Tell me when it's there.
I got it.
Done? So
Yeah.
I can reboot the board, right?
Yep.
All right. I think students in this program are the only ones that don't bat an eye when I say reboot the board. Uh-huh. Well, to show you how nerdy we are, about 10, was it 10? Yeah, it was a little more than 10 years ago. Anyway, one of the grads from the local program, the UPRC program, came and he was my intern, and then he graduated and he became full time. So now he's got his doctorate. He works at NASA. And anyway, he was my office mate for close to 10 years. Really good kid. His name's Tim. So anyway, in the spring or close to springtime, he walks into the office in the morning, and I usually got there about 7:30, something like that. And he usually got there about 8. Anyway, he walks into the office and he looks at me and he goes, "Happy Pi Day," right? And I'd never heard that expression in my entire life ever. As God is my witness, I'd never heard it. In about 2 seconds, I knew exactly what he was talking about because it was March 14th. I don't know if that's impressive or really sad. I'm not sure. My wife would say it's both impressive and sad. Okay, we got homework due, right?
Yep.
Homework number 1. When's it due, guys?
The 5th of October.
I gotta see if I can get Sam and Josh to grade it. That'd be awesome. We've had enough material now that we can actually jump and take a look at some probability problems that are similar to our example. We haven't done that yet. We're kind of skipping around a little bit. Let's do 249. So homework number 2, we're gonna make this do, what's today, the 28th, right?
Yeah.
So this will be due on 10/14, okay, guys? So chapter 2, number 49. 49's easy. So is 51. Let's do 53. 53's easy too. Okay, here we go. Any questions so far?
Nope.
Suppose we select a board from from an ENGR 268 class. So the board has president, VP, secretary, and treasurer. Okay? Pretend. All right? How many ways can a board be selected if there are 8 students in the class and each host position and a student can only fill one position. Does that make sense? In other words, you couldn't have the president also be the treasurer. In one position. Okay. I assume you've done something like this before. I assume. Is that correct?
Maybe.
So, so we have the position of president, VP, secretary, treasurer, okay? How many options, if we're just picking students at random, how many options for president?
You'll have 8 options.
8, right? We're just picking students at random, guys. How many for vice president? Remember, the guy we pick, or gal, we pick for president can't serve any other positions. So there's only 7 left. Do you see that we have 7 choices for VP?
Yep.
How many for secretary?
6.
And how many for treasurer?
5.
Okay. Now, so the total, the way we do this is, well, here, let me show you something. If a procedure or operation, whatever, is made up of, can I get rid of important dates, guys?
Yeah, I already posted them.
Thank you.
Yep.
That's much better. Is made up of n sub 1, or n steps, and no, let's have j steps. And step n sub 1, or step 1, here we go. Step 1 can be performed in any of n sub 1 ways. Step 2 can be performed in n sub 2 ways, right? Step 3 can be performed in n sub 3 ways. Step J can be performed in n sub j ways. The total number of ways to do the operation, the procedure, equals n sub 1 times n sub 2 times n sub 3 times n sub j minus 1 times n sub j. You just multiply them together, guys. Okay? Does that make sense?
Yes.
Okay. Let's talk through a really, really simple example. You ready to roll? We're just going to talk through it. Suppose you have 4 tires for your car, 4 brand new tires. Okay? All right. And for whatever reason, the dude who put the tires on, the shop that put the tires on, the rims and all that, sold you the tires, blah, blah, blah. For whatever reason, well, tell you what, how many different ways are there for the guy to put the tires on your vehicle? Well, do you see that the procedure is putting the tires on your vehicle, okay? And there's really 4 steps, right? 1 for each tire, 1 step for each tire. Do you see that?
Yeah.
And each one of those steps can be done in a certain number of ways. So step 1, the very first tire, how many ways are there to select a tire to put on the first position on your car that he goes to? Well, he's got 4 tires to choose from, doesn't he?
Correct.
Right? So, number of ways to install the tires. Install 4 tires. So we have 4 for the first tire, right? That's n sub 1. So I don't know, say he starts at the driver's side front tire, okay? So he's got 4 tires to pick from. He grabs one of the 4 tires, throws it on driver's side front. Then he goes to the next tire, the next position on the car. Do you want the guy to go to the other side of the front, or talk to me? This is left front. Where do you want the second position to be? Right front, passenger front, or something else? Talk to me.
Right front.
Right front? How many tires does he have to choose from for the right front?
3.
3. Guys, this is n sub 2. Do you see that? That's n sub 2.
Right.
Where do you want him to go next? Do you want him to go, let's see, left front, right front? Do you want him to go right rear? kind of in a circle.
Wise.
That's easiest, trust me. So right rear. How many choices for tires for the right rear?
2.
2. Yes, guys, it's that easy. Times, and then we have the left rear, right? He's only got 1 tire left. So there are 24 different ways. You probably never thought of it that way. If you got a set of 4 tires and 4 positions on your car, there are 24 different ways to put those tires on your car. Probably didn't think of it that way. I wouldn't. Okay? Do you see that? Okay? Do you see that it is completely and totally in line with what we said here? Okay? You can think of it as an assembly line too, right? You're making a widget on the assembly line, okay? So the first step, you got a box of parts. First step, you pick one of those parts. Well, how many parts can you pick from? That's n sub 1, right? Second step, you put another gizmo on the thing that you selected. How many of those gizmos do you have? Well, you got n2 of those, and so on until you're completely done. Does that make sense? We're going to do a subway example in a moment. Okay. How many different ways are there to, in a class of 8 students, how many different ways are there to pick a board of students up among those 8 students? Do you see that it fits this perfectly? You just multiply them together. Do you see that? Talk to me. Okay, what do you get? 56 times 30, whatever that is. Is that 1180 maybe? No, is that right?
1680.
1680. Wow, it's a lot bigger than I thought. There are 1680 ways to select a 4-person board. Okay? Any questions on that? Okay. Are we good? You ready for another example? Okay. Can I get rid of this stuff? Now, who's been to Subway lately? You have? What's that? Do they have like breakfast subs or something like that? Or was it? What? Okay, all right. So you go to Subway, right? We went on vacation. And believe it or not, this is pertinent to the example. We went on vacation back in, June, July? July. It was right after 4th of July. And one of the places we went to, we went with the kids and grandkids. One of the places we went to was the amusement park in Hershey, Pennsylvania. Total tourist trap, ungodly expensive, but that's beside the point. They had a miniature subway inside the park, okay, which was actually a godsend because you could go and order the $8 French fries and that were horrible, and your $10 hamburger, which was equally horrible, or you could order a sub from literally a Subway restaurant inside the park for half that cost. Well, guess what I did? So, but it was a limited Subway. Okay, so they didn't have, if you wanted one of these whacked out sandwiches, you probably couldn't get it. So like everything was like a 6-inch or either 6-inch or 12-inch, and they only had like a few types of bread and stuff like that. So, do you want to do the example of the full-fledged Subway or kind of a reduced scope Subway? Because here's the question. How many subs are possible at Subway? That's the question. If we do the full-fledged Subway, we're going to get a pretty darn big number. Actually, we're going to get a big number anyway, but do you want to do the full-fledged Subway?
Yeah.
Okay. So, do you see that the steps in making a sub fit perfectly in here? What kind of? Right? If each step doesn't matter what happened previously, they're all, in other words, they're all independent, which we have to define that, which we're getting to. But in other words, the type of bread that you choose, the type of bun, doesn't affect the type of meat that you can put on it, which doesn't affect the type of veggies you can put on it, which doesn't affect the type of sauce that you can have them put on it, okay? And cheese and all that, right? So everything is independent, okay? So if you're at Subway, what's the first thing that the do they still call them sandwich artists at Subway? They used to. That was before your time, though. Do they just call them, Subway employees now or something? I don't know. They used to call them if you Google it, you got to go in the Wayback Machine. It's probably 15, 20 years old, but they used to call them a sandwich artist. Anyway, what's the first thing that Subway worker does? First thing they ask you to select. What is it? What type of bread? How many types of bread are possible? How many types? 6? How about if we go 6? Because the numbers are going to be ridiculously big anyway. Then they ask for what? You get a white, wheat. There's some weird cheese bread kind of something or other, right? Urban cheese. What else is there? Okay, so if you get a wrap, like a tomato basil thing, can you still get all the sub sandwich ingredients inside of it? I assume you can. Okay, so that would count, right? Next thing is size, right? How big? So can we go 2 for that? 6-inch or 12-inch, right? Yes, no?
Yeah.
Then what? Okay, meat. How many choices for meat? You can think of half a dozen without even thinking about it, right? Roast beef, at least 6, right? Can anyone think of 7? You got turkey.
I imagine there's probably like 8 of them.
8? Okay. I would agree with you, by the way. The meatball thing, you can get meatballs and still call it a sub. You can get roast beef, ham, chicken, turkey, whole bunch of other things I can't remember. What's that?
Maybe like pastrami or something.
Pastrami, yeah. So that's like 6 right off the top, without even really, doing much thinking. What's next? Cheese, right? How many types of cheese?
3 or 4.
Is it only 3 or 4? American, mozzarella, Swiss,
Provolone.
provolone. Anything else?
Said American.
American, Swiss, provolone,
You said mozzarella.
cheddar. There's at least 5, right? I'll write them down. American, Swiss, provolone. What else? Cheddar. Is there do they give cheddar? Mozzarella. I know they give mozzarella.
I haven't been there in a long time, so I'm not certain. Do they have pepper jack?
I don't know. So 6, right? I'd be surprised if it's less than 6. What's next? Veggies, right? I know. For this example, okay. It's really a binary thing, right? You can get lettuce or not. You can get tomatoes or not. You can get olives or not. You can get onions or not. So it's really 2 raised to the number of veggies they have. And I'm thinking, so what? Onions? Lettuce? Yes, no? Talk to me, guys. Come on.
Tomato.
Green peppers. Oh, I forgot that one. Spinach. Raw spinach is pretty good, actually.
Tomato.
Tomato. You say tomato, I say tomato.
Olives. They have banana peppers too. Oh, yep.
Is that a choice?
Yeah, it is.
Japolino. What else? Cucumbers. Don't forget the cucumbers.
They have pickles.
Pickles. Don't forget them either. Without even thinking, we have 10 veggies. You can get any or all of them, right? So you can either get onions or not. Same thing. So this is 2 raised to the 10th power. Do you see that? There are literally 1,024 combinations of veggies. Without even thinking, we generated that list, right? What's after veggies, guys? Toasted or not? Yes, no? Isn't that a choice? Well, that's a binary thing, just like size. What's next, guys? Is it the topping, the sauce thing? Yes, no? I'm thinking at least 8, right? You know, those are the squeeze bottle things they have at the end, right? How about if we go 7 just to make it a little different, because everything's an even number. Okay, guys, do you see that how many subs are possible? We got to multiply each and every one of these, right? Because it fit. Go.
Why was veggies like 2 to the power, but not like meat?
Because you can't.
All the meats.
Can you get all the meats for the
I don't know
same
if you
price?
can get all of them, but there's like combinations.
I know. We got to make things somewhat simple.
Okay.
You know, it's easy to make the veggies simple because, you know, you can literally get anything you want. With meats, like you said, you can get some combinations, but not all.
Okay.
Just like cheese, you can probably get multiple. It's probably 2 raised to the 6th. Can you get all cheeses? I don't know. I have no idea. I don't know what the rules
Maybe
are.
like 1 slice of each or something, like spread it out.
Yeah, probably. Yeah. So, 10, yeah. Well, we're getting there, but the way we set it up, each veggie is a choice of yes or no, and they're all independent. The veggies themselves fall under this rule as well, right? Right? So, all right, you guys ready? We got to multiply these. By the way, guys, one thing that, and I will change marker colors. This thing right here, where you multiply them all together, this is called the multiplicative rule. That's what that's called. All right. So in our subway example, it is the classic multiplicative rule that we have. Okay. So the number of subs equals 6 times 2 times 8 times 6. You guys are going to have to do this on your calculators. Times 14, right? 2 times 7. I ran out of room. It's going to be a big number. It's going to be in the millions probably. What do you get?
8 million.
How many?
57.
8 million. 247. 257.
536.
And somewhere out there, I bet pretty much each and every one of these combinations has been served somewhere,
Oh, I hope not.
or at least the vast majority of them. Although it would be kind of hard to imagine a sub with 10 veggies on it, I would think. Anyway, but yeah, that's how many subs there are. Okay. All right. Are there any questions? So, how much time we got? How much time we got left?
We still got almost a half hour.
Ah, cool. Are we having fun? I hope we are. So, using the multiplicative rule, that's what we got, guys. That's what we have. Now, ready to move on? Because we have to make some definitions now. Ready to roll? Here we go. Can I get rid of these? Going once, twice? Okay. Now, what's a good example? Does anyone have a significant other or something like that that's involved in, childcare or teachers or something like that? Kindergarten teachers? Anyone? Family member?
Mm-mm.
What does she teach? Okay. Estefan, right? Has to organize all. So how many in a typical class? Like 30 students, 24 students, something like that? all the kids in general in her class. Okay? She chooses each child at random until they are all organized. All are organized in a line. In a line. Okay? How many ways to organize? Well, 22, right? How do you get 22 factorial? We don't even know what that is yet. How many choices for the first child? 22, right? Guys, come on, just humor me. I already know you know the answer. 22 for the first one. How many for the second? First child's already selected. 21, 20. Do you see that we have the multiplicative rule? Yes, no? When do we stop?
The last child.
Do you see that? So this equals what we call 22. What is it, Esteban? Okay, not to be confused with yelling 22. Okay? What's 22 factorial or 22? What is it?
Oh, that's really bad.
Oh, it's huge. It's well into the millions, maybe billions. Estefan, your mom has to get smaller class sizes. She's really screwing up our examples.
I got 1.124 times 10 to the 21st.
Oh my God, that's well into the trillions, right?
That's a lot.
Well, that's what you get with factorials. They blow up big time, right? Right? Just as a refresher, okay, because you guys have had factorials before, I'm sure. Okay? 0 factorial, by definition, is 1. It's a definition. It doesn't make any sense. That's one of the few things that you just need to accept as a definition, okay? It's required because we're going to see some examples where we're going to be dividing by 0 factorial. Well, go. Yes, it is. But at least that's not a definition, right? At least that works. What's 2 factorial?
2.
3 factorial?
6.
4?
24.
You see that it's going to get big real fast. 5 factorial is 120. 6 factorial is 720. 7 factorial is 5,040. It's pathetic that I know these. 8 factorial is 40,320, maybe. Is that right? Talk to
Give me a
me.
second. 40,320.
Okay, that's what I got.
Okay.
9 factorial is 362 or something like that. 362,000 or something like that. Help me out, guys.
62,880.
And therefore 10 factorial is 3, 6, 2, 8, 8, 0, 0, which is 3.6 million and change. Okay? All right? And after that, they blow up even faster, obviously. Okay? But have that list, handy. Okay? Now, are there any questions so far, guys? Everybody's familiar with the factorial, right? I mean, you've had it before somewhere along the line. Help me out. Is this completely foreign to anyone? We good? Okay. Now, Esteban's mom, would she be, would that be, your last name's Ortega, right? Esteban? Is that Mrs. Ortega then? Is that what Mrs. Ortega now selects a group, a group of helpers. Each with a specific title. I don't know what second grade people do, second grade students do. Maybe it's for like a school play, something like that. How many helpers for a school play? Maybe 6? 6 or 7? Does that sound reasonable?
Yeah.
Yes, no? So let's go 7. 7 helpers, okay? So, guys, how many ways are there, does Mrs. Ortega have to select 7 helpers out of 22? Well, we have 7 helpers, right? Right?
Yes.
So she has 22 choices for the first one, right? Completely random, of course. And then 21, 20, 19, 18, 17, 16. Yes, no?
Yes.
So you'd multiply all these together by the multiplicative rule, which we've done. And what's the number you get? I have no idea. It's going to be a lot lower than what we started with. The 1.24, whatever it was. Probably in the hundreds of thousands or millions. 500 and how many? I don't think I buy that. It's got to end in 0.
Yeah.
541, 760. So it's in the hundreds of millions. Is that right? Talk to me, guys. Yes, no?
Yeah.
Okay, now, I want you to think a minute. We can approach this a different way. Okay? Given a set of n objects, in this case, children, with k objects selected from the n. So clearly, n is greater than or equal to k, correct? You can't select more objects from what you got, right?
Yes.
Right. So the total number of ways to select the k objects from n total, where order matters. And that's really important. Order matters. Okay? I assume the black marker is kind of running out of gas. Is that correct? It sure looks like it to me.
Bit.
Okay, let me switch. This is called a permutation. This is coming through a lot better, is it not?
Yeah.
Permutation, which is written P objects N K. Are you familiar with that notation, guys? What's that? Have you seen this before?
I have not either.
Really? Have you heard of the term permutation? Okay. It's a permutation. And it equals, by definition, this is the definition of a permutation. N factorial, okay, if we were selecting each and every single object, in other words, n equals k, this is what we would have, is it not? Because that's what we had up here. N factorial. If we're selecting a subset, in other words, k is less than n, we have to, which is what we have here, right? Right, guys? Right? We didn't select each and every kid, each and every student in the class. We only selected 7. So this equals 22 factorial divided by 15 factorial. Do you see that? What's left over? Yeah. So this upstairs is obviously n factorial, at least I hope it's obvious. Downstairs we have n minus k, quantity factorial. So that's what we have with a permutation. Okay? Yes. Yeah. Yep. Yep. Can I erase this down here? Here's another example. What's a group of people? Suppose a department at work has, I don't know, 30 people, 30 employees, and 6 are selected as a board. Thank you. So you got a department of 30 employees. It might be, I don't know what it is. Maybe it's a ball team. I don't know. But it's got 30 people in it, and we're going to select 6 of them for some board where order matters. In other words, each one's going to have a specific title. Okay, so they're not going to be, if you have a group of 6 that are selected, if the same, a different time, if the same 6 were selected but to different posts, that would be different. Order matters. Okay? So, how many ways are there to do this? Well, it's clearly n, I hope, right? N equals 30, k equals 6. Yes, no? Talk to me. So this goes to the permutation of n, which is 30, k equals 6. So it's 30 factorial divided by 24 factorial. Okay, which is going to go back to our original multiplicative rule, 30 times 29 times 28 times 27 times 26 times 25. What do you get? A pretty big number, but not incredibly horrible. It's going to be times 1,000. It's going to be divisible by 1,000. I can tell you that.
Did you want the number?
Yeah.
Yeah, I got 100,000. 427,518,000.
I should have picked a smaller group. Anyway. Okay, so that's how many?
It's 427. 427.
Oh, okay. Can I get rid of this stuff over here? Going once, twice. Okay, now let's take, we got 2 situations. We have Mrs. Ortega and her selection of, 7 students?
Yeah.
Right? Suppose Mrs. Ortega selects 7 students to serve on a committee. On a cleanup committee. After, I don't know, doesn't matter. Committee's 2 T's, 2 E's, right? Is that right? Is there one too many T's? It doesn't look right. Anyway, out of 22, right? Order does not matter. Okay? So, number of committees equals. Well, we already know that it's the permutation of 22 things taken k at a time, right? Which is 7. Yes, no? We know that from our earlier work, right? Talk to me, guys. Well, we said that order doesn't matter, though. Okay? So a committee of Bobby, Charlie, David, Edward, Franklin, Adam, George, right? 7 students, right? This committee is identical to, what was B, Bobby? If Bobby was chosen first, and then George was chosen, and then Adam was chosen, and then Frank was chosen, and then Edward, and whatever else I'm missing, Charlie and David, right? These 2 committees are identical, are they not? Even though they were selected in a different order. Do you see that?
Yes.
Order doesn't matter. So here, we have to divide by, if order doesn't matter, we have to divide the permutation by the number of ways to arrange the objects, which is, in our case, is 7 factorial. Because we have 7 members on the committee. How many ways are there to arrange those 7 members? Well, 7 times 6 times 5. Do you see that, guys? This is called a combination of k things taken n at a time. I'm sorry, n things. I'm mixed up. Taken k at a time. And this equals the permutation of nk divided by k factorial, which also equals n factorial divided by n minus k quantity factorial, k factorial. Okay? All right. So for our example, we'll do the math here and then we got 5 minutes left ish?
4.
4? Okay. So, for example, we have 22 factorial divided by 15 factorial. Yes, no? Yes, no? Right? Well, this equals 22. I'm going to show you a way in case you don't have your calculator or your computer with you. In other words, if you have to think. It's really not that bad. If I stop at 16, I've taken care of dividing by 15 factorial. Yes, no?
Yeah.
Well, this problem isn't horrible. Yes, no?
Oh.
Right? 6 times 2 is 12. So, here, I'll leave the 2 up. So 18 over 6 is 3. So that's what we end up with. Divide there. So we have this equals 11 times 19 times 3, 17 times 16. Okay? And if you absolutely positively had to, you could do that with pen and paper. What do you get? It's a lot lower than what we had before, I can tell you that.
84,825.
And what number did we get before?
859 million with change.
Quite a bit smaller, right? This is a really good stopping point, guys. We'll pick it up here on Thursday. Does anyone have any questions for the class?
I'm glad we did that because that explains the order matters thing better in my head.
It all boils down to, if we just pick a group versus, okay, we're going to pick a group and the order that we pick them, that matters, okay? So, like, what this boils down to, guys, the order thing in the 30 seconds we have left. The order thing boils down to if the objects are uniquely identifiable, right? In other words, children have names, okay? And if, or if the group we're choosing them for, if that order matters, in other words, each position in that group has a title, like president, vice president, secretary, treasurer. Okay? That's what it boils down to, whether order matters or not. Okay? if you're a cook and you're just selecting a bunch of potatoes and you have to select 10 potatoes from 30, order probably doesn't matter. So that'd be a combination, right? You'd have to put little numbers on each potato, but anyway. I guess you wouldn't. Anyway. Any questions, guys? Well, we're going to do a lot more examples, so I hope any confusion you might have will be addressed. If there's any lingering confusion, it will be addressed at that time as we do more examples. Okay? Is that a deal? All righty. I will see you guys on Thursday, okay?
All right.
Okay. Take care, guys. Bye-bye.